The expression 2x cubed minus 3x squared plus x minus 7 is a polynomial. Polynomials are very important in mathematics. For example, they can be used to produce curves that fit data points generated by experiments. Here, the black curve is defined by the polynomial expression shaded in green. Polynomials can be used to generate curves that fit complex shapes like this letter A. These curves are called splines. The splines are based on cubic polynomials, where the highest power of x is 3. Polynomials can be used to represent the behavior of physical systems. Here we see a quadratic polynomial representing the motion of a projectile. Polynomials can be used to generate curves that approximate functions like sine, cos, exponent, log, and so on. These are called Taylor polynomials. Here, the polynomial called g of x is a good approximation to the sine function near the origin. Polynomials can be used to represent mathematical word problems algebraically. Here, the area problem on the left can be represented by the quadratic polynomial equation on the right. A differential equation is an equation which involves the rate of change of some variable. Polynomials are often used to represent the solutions to such equations. Here we can see the Hermite differential equation. It has an infinite number of solutions, one for each value of n, and each solution is a polynomial. To make a polynomial, we add together a finite number of terms. A term is made by multiplying a constant, which just means a number, and one or more variables raised to non-negative powers. Here we see some terms that may legally appear in a polynomial. So we have 3 a constant, x a variable, 2 a non-negative power, minus 5.2 x to the power 5, pi a constant, x to the power 2, y to the power 7, 1/12 constant, x variable, and a positive power of 1, 2.7 constant, x raised to the power 0, a non-negative power. And we recall that we can write x equals x to the power 1, 2.7 equals 2.7 times x to the power 0. Here we have some terms which cannot appear in a polynomial. The term 3 over x cannot appear in a polynomial since 3 over x is equal to 3 times x to the minus 1, and minus 1 is a negative power. Similarly, sin x cannot appear as a term in a polynomial since it cannot be represented as x raised to a positive power. In general, terms in a polynomial may have more than one variable. So, for example, we've seen a term containing x squared y to the 7. However, the most important type of polynomial is based on a single variable, which we usually call x, and we will only consider such polynomials in this video. Here is a typical term in a polynomial. The 3 is called the coefficient, x is called the variable or indeterminate, the 2 is called the power or exponent or index or logarithm, and a coefficient can be any real number, positive, negative, or 0. A polynomial is the sum of a finite number of terms. Here, each blue box contains a single term, and in fact there are 10 plus 1, i.e. 11 terms in this polynomial. However, the term whose coefficient is 0 would usually not be written. So we would see only 10 terms written in this polynomial. We now consider some expressions which look similar to polynomials, but which are not. This expression is not a polynomial because the ... at the end signifies that there are an infinite number of terms. Polynomials may contain only a finite number of terms. This expression is not a polynomial since it is a fraction with one polynomial in the numerator and one polynomial in the denominator. Expressions like this are usually called rational polynomial functions. This expression is not a polynomial since the final term contains x raised to the power -1. And this expression is not a polynomial since the variable x can only appear as a base, not as a power, in a term of a polynomial. We usually write a polynomial in standard form, which means with the terms either written in order of decreasing powers of the variable or in order of increasing powers of the variable. So both of these expressions, which show the same polynomial, are in standard form. The first is written with powers in decreasing order, from left to right. The second is written with powers in increasing order, from left to right. However, this expression, which again represents the same polynomial, is not in standard form. Usually we rewrite a polynomial so that it is in standard form, because that makes two polynomials easier to compare. The leading term of a polynomial is the term whose variable is raised to the largest power. The leading coefficient of a polynomial is the coefficient of the leading term. The degree, or sometimes order, of a polynomial is the power of the leading term. Here, the blue box indicates the leading term. The leading coefficient is 7 and the degree is 4. Again, the blue box indicates the leading term. Here, the leading coefficient is -1 and the degree is 1. This polynomial has only one term, a constant. It has a leading coefficient of 8 and a degree of 0. We can classify polynomials by the number of terms that they have. So a monomial has one term, like x. A binomial has two terms, like x plus 1. A trinomial has three terms, like x squared plus x plus 1. The most commonly used of these expressions is binomial. And the binomial expansion tells us how to expand an expression like x plus y to the power n. We can also classify polynomials by their degree. A degree 0 polynomial is a constant, a degree 1 polynomial is linear, and linear polynomials are so called because they define straight lines in the xy plane. A degree 2 polynomial is a quadratic, a degree 3 polynomial a cubic, degree 4 is a quartic, and degree 5 is a quintic. And although you won't often come across quintic polynomials, they are important historically. There is no general solution for a quintic equation, whereas there are general solutions similar to the quadratic formula for linear, quadratic, cubic, and quartic equations.